Okay, in this video, we are going to talk about circuit analysis. So, when you recall about circuit analysis, you must remember all the different formulas that you have. So, if you can see the bottom screen, there's actually all the formulas over there for series and for parallel. So, even your potential divider rule as well as your current divider rule, they are all inside here. Okay, so whenever we look at a circuit like this, first thing first, we need to see what are the values we are given. So in this case, you have A2, you have A3, alright, as well as R1 and EMF. So when you have R1, okay, first we recall that we have this formula of R equals to V over I. So with R equals to V over I, as long as you have any of the two values, R, V, R and I, or V and I, you can find the third value. So in this case, we try to find what are the values that, which of this resistance actually have both of these values. So for example, you look at R1, R1 is 5 ohms, and we know what's the current going through it, it will be 1 ampere. Okay, so because of that, we can find, okay, so A2 is 1 ampere, A3 is 1.5 ampere, so we can actually find what is A1. So A1, using the formula, you notice that A2 and A3 are actually in parallel to, and A1 is actually in series. So actually, we can make use of the first formula, that I total equals to I1 plus I2. So in this case, for A1, A1 is actually equals to A2 plus A3, which are the values that we have been given, 1 ampere plus 1.5 ampere. So this actually equals to 2.5 ampere. So 2.5 ampere is now the total current going through the whole circuit. Right, so you know A1, you know R1, you can actually find V1. So V1 is equals to I1 times R1. So you actually have 1 ampere times 5 ohms. So that gives you 5 volts. Okay, now right now that you know that V1 is 5 volts and you know the EMF is 20 volts, you will know what is V2 and V3. Since V2 and V3 are parallel, V2 and V3 must be the same. So, we remember that in series, V1 and V2 will give you the EMF. So V2 is actually equals to EMF minus V1. Now we do not need to consider V3 because V2 and V3 are in parallel. So the potential difference across that whole parallel branch is actually considered as 1. Okay, so you need to consider it once when it's in series to V1. Alright, so what we have right now is actually 20 volts minus 5 volts, and that leaves us with 15 volts. Okay, so V3 actually equals to V2, so we will have solved this. This is also equals to 15 volts. So for R2, R2 is actually equals to V2 over I2. So we know V2 is 15 volts. R2 is given to us as 1 ampere. Therefore, R2 must be 15 ohms. Likewise, R3 equals to V3 over I3. V3 is 15 volts. A3 is 1.5 ampere. So we actually have 10 ohms. Okay, so with this, we can actually go one step further. We can actually calculate what's R total. But of course, you know that since you have EMF and you have I total, you can calculate R total easily from there.